So this is the first period video where I'll be working all of the ones we didn't do yesterday. So there's the Monday problems. This video is all the others. Except for 1 and 2, because those are too easy. So, 4. A vendor sells small drinks for $1.15, medium drinks for $1.75, large drink for $2.25. During a week in which he sold twice as many small drinks as medium drinks, his total sales, they're like squeezing 3 equations into one statement here. Total sales was that much, and total number of drinks was that much. Okay, so I'm pretty sure we're going to go small, medium, and large, SML. So this maybe feels out of order, but the 1385 drinks is the easiest one. S plus M plus L is 1385, because that's the total number of drinks he sold. His sales is a pretty easy one, because the small drinks cost $1.15 for each small, $1.75 for each medium, so times the number of medium drinks, and $2.25 for each large. And he made $22.38.75. And then lastly, twice as many small drinks as medium drinks. Twice as many small drinks. So I think I want to multiply the medium by 2. Right? Because if he sold 5 medium drinks, that means he sold 10 small drinks. Sometimes you got to plug in like actual numbers to figure out where the 2 goes. Twice as many small drinks. Yeah, that does look like you should multiply the S by 2, but that's not right. You want S to be equal to twice M. Okay, so let's see if we can matricize this. How's that for a word? So 111, that's an easy one. And that equaled 1385. That's the total number of drinks the guy sold. The next line is pretty easy. It's in order as well. So $1.15, $1.75, $2.25. And I probably didn't make my matrix large enough to fit the dollar amount there. And then the last one is one I need to be careful about because it's not in the right format yet. I'm going to move the 2m over. So S minus 2m equals 0. So 1s minus 2m equals 0, and larges weren't involved in that problem. Remember, there's there's a ton of different ways to write that matrix. Because one easy way would be if you had made this 2m minus s. So your 2 would be positive and your s would be negative. And that would not change your answer. Another way to tweak this matrix is you didn't have to put them in that order, the rows in that order. You could have done a different order. You also could have done a different order for the variables. So on the free response question on the test, when it comes to this one, I've got to be super careful grading it because we tried to calculate it yesterday. It was like over 200 different ways you could arrange things. So over 200 different matrices that still give you the same answer. Yeah, I went small, medium, large, but if you put them in alphabetical or some other method, large, medium, small, it doesn't matter, but you just got to be careful. Okay, how many of each drink were sold? Well, we don't know because we're stopping there. The vendor decided to increase the price for small drinks to $1.25 the next week. The next week he sold 140 fewer small drinks. Oh, well, there's no way to answer B without having the answers to A. So calculate his sales. Like, I can't do that because I don't know the answer to A yet. So we'll have to just skip that. We just can't do that. And then C would just be, well, where did he make more money? But since we don't know the answer to B, we can't answer C either. That's a skip. Ship. What does ship have to do with this? Number 5. So just, who's right, Cody or Megan?
It's Cody.
Wait, what was that? I thought I heard different answers. Who's right?
Jackie said it was Cody. I just said Cody because Cody's right here.
I think I'm wrong. But Cody is wrong. Cody is wrong. Megan is right. And the trick there was they wrote that second equation sort of out of order to see if you're paying attention. 4x, 3y, 4x, 3y. So Megan is right. Sorry, Cody. Do better next time. But you can see where that might be a common mistake if someone wrote those out of order to get the matrix messed up. Number 6 you did yesterday. Not hard. The only trick would be the domain. And the only one that mattered for is the f over g. X is not 1/3. Make sure you can do that in interval notation, though. Number 7 we did a few minutes ago. Number 8, f of g and g of f. We did 8, you're right. And we did 9. We're cruising. You good on 9? I mean, h of 3 isn't bad, but h of a plus 4? And then plugging that into f?
Yeah.
Okay. Number 10, find each, g of negative 6. How many times are we going to ask you to square a negative and then multiply by a negative and see who can get the sign correct? Negative 72. Because the square of negative 6 is 36, times negative 2 is negative 72. G of 3/2 is going to be mildly annoying because of the fraction, but that's okay. Negative 2 times 9/4 would be negative 18/4, which reduces, or you could sort of reduce first and get 9/2. Either way, you're landing at 9/2 and reducing by 2, so whichever.
Oh.
Which one do you hate? C? H of 2a. The square of 2a times negative 4 minus 2 times 2a plus 5. Be careful, make sure you square the 2 and the a. So 2a squared is, let me phrase that differently. The square of 2a is 4a squared. So negative 16a squared minus 4a plus 5. And that's it. So that wasn't bad. The trick there is going to be, are people going to square the 2 and the a, or are they only going to square one of them? I hope they square both of them. We skipped number 11. Or no, I don't think I told you to skip number 11. But I'm telling you now, skip number 11. Right, because I looked over the test and decided we should skip number 11. 12, we did B, and B worked, right? You got f of g to be x and g of f.
You told us B didn't work anyway.
A doesn't work. Let's do it, though, because for inverses, if you want to find an inverse, you switch x and y. But if you want to verify or prove or see or determine, then we use composition of functions, especially when it just flat out says, use composition of functions. That means f of g of x equals x, and g of f of x equals x. That's what composition means. That's the g of f and f of g, the fog and the goff.
That's so difficult.
It's, I don't know, is it difficult or is it just annoying? Or are those the same thing? So, I think it's helpful to show more steps. A bunch of you are not showing steps, and you have a bunch of work on your page, and I can't figure out what you're trying to do because you didn't label things. F of g of x. So f of 2x minus 4/3, which means now I'll look at the f function, and in place of x goes 2x minus 4/3. So x, that's good news, so I'm sort of on the right track.
4 or 6.
Minus, I'm going to reduce the 4 and the 2 and get 2/3. And I don't think you have to be a fraction expert to say that that's not equal to x, right? I don't even need to get negative 2/3 plus 3/4. That's not canceling out.
So whatever it is, it has to cancel.
I mean, it doesn't equal x. It's got to reduce or cancel all the way down to x.
The x, what is x equal?
It doesn't matter what x equals. What matters is what f of g of x equals. So you shouldn't get it. If it doesn't get all the way down to x, then it's not an inverse. And if this one doesn't get all the way down to x, there's really no point in doing g of f of x.
Because we already know that one.
Because one of them doesn't work, and they both have to work. So as soon as one of them doesn't work, there's really no point in doing the other. So that means f and g are not inverses. Now, 12, you would have to do both, but they both work.
I didn't even do that for 12. I just switched the x and y.
If you switch the x and y, I'm going to give you half credit because you will determine if they're inverses, but you will not have used composition of functions.
If it doesn't say composition of functions, you don't have to do that.
That would be right. If it doesn't specify,
Are you going to...
I'm going to specify.
I'm going to need a bottle of whiteout.
A bottle of whiteout.
Are you putting those on?
Okay, number 13. Here we go. Find the inverse function. Here's what you wanted to do all along. What do we do to find the inverse function? Switch the x and y. So x equals negative 5/3 y
This test is looking because
minus 8. Wherever there was a y, put an x. Wherever there was an x, put a y. Except I'm not done yet because I need to solve for y. So x plus 8 equals negative 5/3 y. Let's multiply by negative 3/5. So y equals negative 3/5 x. That's easy enough to deal with for slope because it's already like up and over, or I guess down and over in this case. And then minus 24/5. It's kind of annoying.
how...
It's almost right.
Almost
Almost
negative.
negative 5. If we're gonna, it does say graph it, so let's get practice graphing here. Minus 8. It's down to there. Down 5 over 3. Well, I'm going to go 1, 2, 3, 4, 5. 1, 2, 3. Goodness, need a magnifying glass to. So there's the original. The inverse, yeah, like you guys said, that's almost negative 5. 1, 2, 3, 4, 5, and on that graph, like, is there any difference between my dot being at negative 5 and being almost negative 5? Like, not that you can tell. Down 3 over 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. And there's my inverse. And we didn't do it on this graph, but inverses are always a reflection across y equals x. So if you folded that graph on y equals x, the pictures would match up to each other. that's why we have you graph inverses. It sort of verifies that your equation is probably right. If you can see that folding across y equals x would make it match up. 14 you did. Were you good with 14?
Yeah.
That's the going back to the left and right is the backwards one, up and down it's kind of normal. This one had a slope of 2, so you have to be careful about that. This one has a slope of 1.
Oh.
Catch that. 15, solve each equation. So let's divide both sides by -2. Because we can't, right, it equals negative, so maybe you're worried, but you don't make that decision until the absolute value is by itself. So 5y minus 1 equals 5. Some of you don't show that step, and it messes you up because you don't know where to go when you drop the absolute value bars. From there, then that's when you split it into two pieces. 5y minus 1 equals 5. 5y minus 1 equals -5. So 6/5, and this one, -4/5. And if I had all the time in the world, I'd go back and check it. But why don't I need to check that one?
Because we know it works.
How do we know it works?
Because there's an equal sign other than greater than one.
It's not even that. It's not the fact that there's an equal sign. What makes B different than A?
Variable on one side.
Yeah, if all my variables are inside, I'm going to be okay. If I've got a variable on the outside, that's when I'll have to be careful.
Oh, I didn't check.
So I'm pretty sure on B, I think one of the answers works and one does not.
Yeah. So -8/3.
So
This one.
why is it? Okay, C might be no solution, but I can't tell yet.
Yeah, -2.
Now, when you subtract the 8 over, you're pretty quick to realize, wait a minute, something is not right here. I guess officially I shouldn't claim it yet. I should get the absolute value thing by itself. And absolute value equals -1. That's no, that never. So again, don't make the call initially. You can't really tell. Get the absolute value by itself, and then you can make that call. And A and C are good examples of that, because A starts out with a negative, so maybe you're suspicious, but it ends up working. C, there's hardly any negatives in the problem, and yet it's no solution once you move things around. (16) What is the solution set? Meaning, what set of numbers works in that problem? Well, my answer choices are really only -3 and -4. So there's sort of two ways to work this problem. One would be to like solve it like normal and see what the answer is. The other would be, well, if I'm going to have to check these anyway, why don't I just check them from the beginning and just plug in -3 and see if it works? And plug in -4 and see if it works. So 3 minus -3 would be -6 plus 7 is 1. 3 minus 1 is 2. Yes. So -3 works. Okay, so now it's either A or C, because -3 needs to be part of my solution set. Let's check -4. 3 minus absolute value -8 plus 7 equals 2. Does that one work? Yes. Some people, they get thrown off by absolute value. -3 minus absolute value of -1. What's the absolute value of -1? 1. So, oops, that wasn't negative. 3 minus 1 is 2. So -4 also works. So my answer is C. Now, again, the real way would be subtract the 3, divide by -1, set up the two equations, and you'd get both of those answers. But since they're starting you with the answers, why not just plug them in and see if they work? That's the joy of a multiple choice test. All right, 17. You did B and C already, so let's do A and D. Although absolute value of Q is greater than -1. Absolute value is greater than -1. That's it's like, yes, that is true always. Solve each inequality. Graph the solution on a number line. Well, that's kind of silly, I guess, to put it on a number line, but if you want me to, I don't know, it's like one number line on top of the other, because it works for anything. And this one didn't specify, but we'll do integral notation. B is the same thing, right? Oh, yeah, because when you divide by negative, I made a mistake. Divide by -1, it becomes less than. And that won't work. You can't have absolute value less than. It does not matter what's inside there. Some people were thrown off, like, oh, but it's a -5K. Like, I don't care. Absolute value less than a negative, that doesn't work. Ever. So no solution. I'm going to say you don't have to graph no solution. But I guess you could. You would just like have nothing on the number line. It's kind of dumb.
Well, I solved it and graphed it. Yeah.
If you work it out the long way, as long as you remember that this is an AND problem, which means you're looking for an overlap, and there is no overlap. That's sort of the long way. I'd rather you catch it up here, but if you go the long way, you should still get no solution. All right, you did C yesterday. Let's do D. What would you like to do first on D?
Multiply by 6.
Definitely multiply by 6. So absolute value 5f minus 2 greater than 24. Now we go to the split up method. 5f minus 2 greater than 24. Greater, so or 5f minus 2 less than -24. So 5f greater than 26, f greater than 26 over 5. Might be annoying to put on a number line, but it might not matter. 5f less than -22. So f is less than -22 over 5. So yeah, I have no problem putting those on the number line. One of them is positive, one of them is negative, so I don't really even have to worry about, oh, it's a little more than 5, and that one's a little less than -4. Nah. The negative number goes on the left. Positive number goes on the right. Less than, greater than. And this one didn't ask for interval notation. That's probably just an oversight on my part. -infinity to -22/5. Parentheses, because we don't want to include the answer. Right? Parentheses, open circle, dashed lines, they all kind of mean the same thing. Like, don't include it. 26 over 5 to infinity. And then we already did some of number 18. I guess do I need to do 18b as well to finish it out?
No.
Just be careful on this one. You'd be dividing by a negative, so you're going to end up with y less than for that first one. Yeah. Okay, reminder, 2 parts, 5 free response, 23 multiple choice, all without calculator. So there's a couple of those matrix equations, but those are set up but do not solve situations.